In our previous lecture, we spoke regarding adsorption isotherm. We have seen three different adsorption isotherm equations: Friendlich adsorption isotherm equation, Langmuir adsorption isotherm equation, and beta adsorption isotherm equation. The drawback associated with Friendlich adsorption isotherm equation was that it is empirical in nature and there was no theoretical basis for coming up with that equation. The equation was y is equal to x by m is equal to kp raised to 1 by n. Then that concept was being revised where theoretical basis was being involved in deriving an equation. That was being done by Langmuir. But again, when different adsorption isotherms were being evaluated and seen, it was being observed that Langmuir and Friendlich adsorption isotherm equation were only able to explain type 1 adsorption isotherm, type 2 to type 5 adsorption isotherms, which we get when multilayer formation start taking place onto the surface of solid. It could not be explained, and then Brunner, Emmett, and Taylor, these three gentlemen came together and derived an equation which is being known as beta adsorption isotherm equation, and that equation helped us in explaining the type 2 adsorption isotherm as well as type 3, type 4, and type 5. Type 3 and type 5, it is being obtained in rare instances. That also we have seen. Now let us move on and talk about adsorption of liquids on solid surfaces. Adsorption of liquid on solid surfaces have multiple applications. We have discussed it in our previous lectures that decolorization, when we are interested in carrying out to get a clear solution, we need to add some adsorbent which will adsorb the colorant and will give us a clear and transparent solution. Even the concept and principle of adsorption chromatography works onto the solid liquid interface principle. And even the third one was your treatment of poisoning cases. Even weighting and detergency have a concept of adsorption of liquid on solid surfaces. So drugs such as dyes, alkaloids, fatty acids, and even inorganic acids and bases, they can be adsorbed from solution onto solids such as charcoal and alumina. So it is not only the case that during poisoning treatment only we are going to use this adsorption concept. Adsorption principle can also be used when we are interested in knowing the quantity or content of alkaloids or fatty acids or some kind of drugs into the formulation. They can be adsorbed onto the solids such as charcoal or alumina. In our next semester, we'll be carrying out one experiment of determining the adsorption capacity, and at that time we will be allowing acetic acid to be adsorbed onto the surface of activated charcoal. So that is another application of solid liquid adsorption, or apart from your treatment of poisoning cases. The adsorption of solute molecules from solution which takes place onto the surface of solid, it can be treated in a similar manner as that of adsorption of molecules of gases onto the solid surface. So isotherm equations which we have seen for explaining the concept of adsorption of gas molecule onto the solid surface, same isotherms can be used for knowing the relationship of amount of liquid molecules which are getting adsorbed onto the solid surfaces. Only the term which is replaced or substituted in the previous equation which we have dealt with is the concentration term. So substituting the solute concentration for the vapor pressure term which was being used for solid gas system. So the equation which is being used for understanding the relationship of the solute molecules from the solution that get adsorbed onto the given adsorbent. It is being given by equation C by Y is equal to 1 upon BYM plus C by YM. Now C is nothing but it is the concentration of the solute which was dissolved into the given solution. Y is the amount of the solute that is being adsorbed onto the 1 gram of adsorbent. Ym is the maximum amount of solute or saturation amount of the solute that will saturate the given adsorbent surface. So B is nothing but it is the constant. So equation is very much similar to the equations which we spoke in our discussion related to adsorption of gases onto the solid materials. Weighting is the phenomenon where again your liquid and solid interface is being involved. Here adsorption at solid surface is taking place, leading to wetting and detergency. This process involves this solid liquid interface, the tendency of the molecules of liquids to move from the surface into the bulk and decrease the surface of the liquid gas interface, which was being explained by the fact that molecules of liquid undergo very weak attraction from the molecules of gases onto the interface. So when liquid comes in contact with the solid, the forces of attraction develops between the liquid molecules and solid molecules, and this interaction will play an important role. So if we want that weighting should take place properly, the most important thing that should happen is that interaction between the liquid molecules and solid surface molecule should take place properly, and this is why soaking play an important role into the detergency process. In this case, the behavior of the liquid will depend upon the balance between the forces of attraction of molecule in the liquid and the forces of attraction that develops between liquid and solid phases. As we discussed during spreading coefficient phenomena, that if adhesive forces of attraction, if they are greater than cohesive forces of attraction, then and then only spreading will take place. Similarly, if we want that weighting of solid surface should take place by the given liquid molecule, then liquid cohesive forces of attraction which is there must be lesser as compared to the adhesive forces of attraction which that liquid molecule is willing to develop with the molecules of the solid surface. So then and then only weighting will take place. See what happens in case of mercury and glass. The attractive forces between molecules of mercury and glass are much smaller than the forces of attraction which is there between the molecules of mercury themselves. And that's why this is the reason because of which mercury is being used into thermometers. You must have observed this. It doesn't stick to the surface of the glass. And this happens because the cohesive forces of attraction which is there between the mercury molecule, it is greater as compared to the adhesive forces of attraction the mercury molecule can develop with the molecules of the glass. As a result, mercury will come together as a single spherical drop in contrast for water and glass, because in capillary rise method we have seen that water spreads onto the surface of capillary and rise up into the capillary. This doesn't happen in case of mercury. Mercury will move into the capillary tube. In thermometer we see it, but it will not stick to the wall of a glass. So attractive forces which are there between the mercury molecule, they are very much higher as compared to the adhesive forces of attraction it can develop with the glass molecule. In case of water and glass, water molecule develop forces of attraction between the molecules of itself and molecules of the glass, and interaction between glass molecule and water molecule are greater as compared to the interaction and attractive forces between water molecule themselves. The most important action of wetting agent is to lower the contact angle between the surface and the wetting liquid. I hope when we spoke regarding HLB scale, you must have seen one category of surfactant which are being used as wetting agent. The surfactant which have HLB's value between 7 to 9, they are said to be wetting agent. So what is the application, or what is the work that surfactant does? They decreases the contact angle between the surface and the wetting liquid and leads to the better interaction between those two. So what is contact angle? Contact angle is the angle which is formed between the liquid droplet and the surface over which it spreads. See, when contact angle value is 0, complete spreading of a given liquid will take place onto the surface. As contact angle will go on increasing, we'll find that the weighting of the surface is becoming difficult. So whenever there is higher contact angle that is happening between the liquid droplet and solid surface, it is for sure that interaction between liquid and solid surface will not take place properly. And in that case, we'll have to take help of wetting agent. Wetting agents are nothing but these are the surfactant having HLB value between 7 to 9, and the work which will be done by wetting agent is to decrease the contact angle which is there between liquid molecule and solid surface. The contact angle between a liquid and solid, it may be 0 degree, which signifies complete wetting, or it may approach 180 degree, at which wetting is insignificant. So when angle is say 180 degree, it means the molecules of the liquid, it is remaining in the form of drop onto the surface of solid and not developing any interaction with the solid surface molecules. If we use, in that case, if we use the appropriate wetting agent, then this will decrease the interfacial tension that exists between liquid and solid surface and will help the liquid molecule to spread spontaneously onto the greasy surface, increasing the interaction between liquid molecule and solid surface, leading to proper wetting taking place of the solid surface by the liquid molecule, and this helps in detergency. Thank you. This was the last concept related to your surface and interfacial phenomenon. Thank you. This was all about surface and interfacial phenomenon from my side. Thank you.